Hello student, myself Rajinder Kumar, lecturer civil at Government Polytechnic College, Amritsar. Today I am going to deliver a lecture on subject RCC design. The topic of my lecture is concept of pre-stressing. So student, the first question is what is pre-stressing concrete or what is the definition of pre-stressed concrete? The pre-stressed concrete is that concrete in which internal stresses of suitable magnitude are introduced so that stresses resulting from external loading can be counteracted to a desired degree. So, in pre-stressed concrete, the internal stresses are developed in concrete member to counteract the stresses caused by the external forces. So, this is the definition of pre-stressed concrete. The pre-stressed concrete is that concrete in which internal stresses of suitable magnitude are introduced so that stresses resulting from external loading can be counteracted to a desired degree. Next is material used in pre-stressed concrete. What type of material used in pre-stressed concrete? Steel and concrete are the basic material of construction of pre-stressed concrete. So let us discuss first type of material, steel. The high tensile strength steel is used for pre-stressing. In addition to high strength, the steel used in pre-stressing must have a higher ultimate elongation. So, the steel used in pre-stressed concrete should have high tensile strength and higher ultimate elongation. Various form of steel used for pre-stressing are as follow. First type is tendon. The steel used in the form of a tendon. Tendon are high strength tensile wire available in various diameter from 1.5 mm to 8 mm. So, tendon are high strength steel wire having a diameter ranging from 1.5 mm to 8 mm. So, next there is a table. This table show the ultimate tensile strength of the tendon. If the diameter of the wire is 1.5 mm, then the ultimate tensile strength of the steel is 2350 Newton per square mm. If the diameter of tendon wire is 2 mm, then the ultimate tensile strength of steel is 2200 mm. If the diameter of tendon wire is 3 mm, then the ultimate tensile strength of that steel is 1900 Newton per square mm, and so on. For 4 mm, 1750 Newton per square mm. If the diameter of tendon wire is 5 mm, then the ultimate tensile strength is 1600 mm. For 7 mm, 1500 Newton per square mm. If 8 mm, then the ultimate tensile strength of tendon wire is 1400 Newton per square mm. So, this table show the ultimate tensile strength of tendon wire. Second type of steel used in a pre-stressed concrete is wire strand or cable. A strand or cable is a made of bundle of wire spun together. The overall diameter of cable or strand is from 7 mm to 70 mm. They are used for post tensioning system. The diameter of a wire strand or cable is ranging from 7 mm to 17 mm, and these are used for post tensioning system. Third type of steel is bar. High tensile bar of diameter 10 mm or more are also used in a pre-stressed concrete. Third type of steel used as bar having diameter 10 mm or more. Second material of pre-stressed concrete is concrete. The Indian Standard Code recommend a minimum mix of M40 for pre-tensioning system and M30 for post-tensioned system. These mix have high strength and high value of modulus of elasticity of concrete, which result in less deflection. For pre-stressed concrete, M30 concrete mix is used for post-tension method and M40 concrete mix is used for pre-tensioning method because these mix have high value of modulus of elasticity and less deflection. Next topic is advantage of pre-stressed concrete. What are the various advantages of pre-stressed concrete? It eliminates the cracks and help in making the entire concrete section effective, but in RCC only the portion below neutral axis is effective. In RCC, the neutral axis divides the section into two halves. The section lying below the neutral axis is called tensile zone and the section lying above the neutral axis is called compression zone. And the tensile strength of concrete in tensile zone is ignored, whereas in pre-stressed concrete the entire concrete section effective. Second advantage is there, pre-stressed concrete need about one third quantity of concrete and 1/4 of steel as compared to RCC. So, pre-stressed concrete is economical as compared to RCC section. Third advantage is the use of high strength concrete and steel in pre-stressed concrete member result in lighter and slender member that could be possible by using the reinforced concrete member. So, pre-stressed concrete member are lighter in weight. Next advantage, the pre-stressed concrete member are thinner in section and hence there is a great reduction of self weight of the structure, which ultimately affect the economy in the cost of foundation. Pre-stressed concrete member does not require too much strong foundation because these are lighter in weight. Fifth advantage, long span structure are possible. Long span structure are possible in pre-stressed concrete because of reduction of self weight of the structure. Due to light weight, the pre-stressed concrete member are suitable for longer span. Next advantage of pre-stressed concrete is pre-stressed concrete can be safely recommended for the structure subjected to heavy load, impact and vibrations. So, these members are advised to use for heavy load, impact load and the area where there is chances of vibrations. Factory product, that is railway sleeper, electric pole are possible in pre-stressed concrete member, whereas RCC member have to be cast in situ. Pre-stressed concrete member are tested before use, but RCC member cannot be tested as such. Pre-stressed concrete structure deflect appreciable before ultimate failure, thus giving ample warning before collapse. No such indication in RCC structure. So, these section gives sufficient warning before the final collapse. The stressing induced in the concrete member tend to reduce the diagonal tensions. So, in this section there is a very small quantity of diagonal shear. Diagonal tension means diagonal shear. So, these are the advantage of pre-stressed concrete. Next is disadvantage of pre-stress concrete. First is initial equipment cost for pre-stressing is very high. So, initial equipment like hydraulic jack, abutment, casting bed are expensive. Second disadvantage of pre-stressing concrete is cost of high strength material is high. Third, it requires expert supervision and much technical know-how. The construction of pre-stressed concrete member need strict supervision. Fourth disadvantage, pre-stressed sections are brittle because the high tensile steel is used. All high strength steel have higher carbon content. So, as the carbon content is increased in steel, the steel become brittle. Fifth disadvantage is slender section are difficult to transport. So, there are difficulty to transport a huge section. Next disadvantage, pre-stressed concrete section are less fire resistance. Because pre-stressed concrete member are thin in section, therefore, these are less fire resistant. Seventh, it require high tensile steel which is 2.2, 2.5 to 3.5 times costlier than the mild steel. So, high tensile steel is costly. So, this this is the disadvantage of this pre-stressed concrete is it become costly. Next is method of pre-stressing. There are two methods of pre-stressing. The first one is pre-tensioning method and second is post-tensioning method. So, student, let us discuss pre-tensioning method. This method is commonly used for small size member like beam, slab, piles, sleeper and electric pole etc., which can be casted easily in factory. In this method, the tendons or cables are tensioned before the concrete is placed. So, in pre-tensioning method, the tendon or cable stretched before the placement of concrete. The following steps are followed in this method. So, this is the procedure of pre-tensioning method. First step is steel tendon, cable strand or wires are first placed at the predetermined place in the form of formwork. Second step, the one end of the tendon is anchored to the abutment. The tendon are pulled by a tensile force P of predetermined magnitude by using a jack. The other end of the tendon is anchored to the abutment. So, this is the diagram. So, these are the tendon wire, this is the abutment, this is also abutment, this is tendon wire, these are the concrete member. So, this tendon wire stretched with the by means of jack here with the force P. After stretching this tendon wire, the concrete can be placed here. Next, concrete is now placed in the formwork and allowed to cure to get its design strength. Steam curing to be done to save the time. It is possible to get 28-day concrete strength in a day by means of steam curing. So, uh, after tensioning the tendon wire, concrete is poured and allow it to cure. Tendon are now cut at the abutment and between the members cast on the same bed. As the tendon were stressed much below their elastic limit, they will tend to regain their original length. As the bond between steel and concrete is perfect, this will induce the compressive stress in concrete, the compressive force being P. When concrete is hardened, then tendon cut at abutment, now tendon bar are tend to regain its original position. By this, the compressive stress is induced in the concrete member because bond between steel and concrete is perfect. In this method, casting bed is very long, that is about 60 to 120 meter long, and hence several member can be manufactured at a time. Second method of pre-stressing is post-tensioning method. In this method, the pre-stress is induced or tendon are tensioned only after concrete has hardened. In this system, the concreting is done first and a duct is formed in the member with tube or with a metal sheather. When concrete has sufficiently hardened, then tendon or cable wire is passed through the duct. In post tensioning method, concreting is done first, tendon or cable is passed through the duct when concrete get hardened. It is when concrete has sufficiently hardened, then tendon or cable is passed through duct. It is tensioned and anchored at its end. The pre-stressing force is transferred from the tendon to the member through the anchorage wedge. Then these tendons are stretched by the mean of jack wedge on the both side of the tendon wire transfer the pre-stress force to the member. The space between the tendon and the duct is filled with the cement grout. Post tension method is pre-stressing is used for both precast and cast in situ construction. It is used for large span structure. Thus, this method, the post tensioning method, is suitable for precast or casting at a site. So, this is the tendon wiring diagram. This is the duct. When concrete get hardened, then this tendon wire is stretched by the mean of jack. Then the after tightening the wedge here, so this gap, this duct gap is filled with cement. Next, advantage and disadvantage of post tensioning method. Post tensioning can be done in factory and at the site also. So, this method is suitable for factory as well as site. The loss of pre-stress is less as compared to tensioning method. So, in post tensioning method there is a small loss of pre-stress as compared to the pre-tensioning system. This method is used for large span and heavily loaded structures. So, the post tension method can be used for heavily loaded structure and large span. The disadvantage of post tensioning method is that it is costly as compared to pre tensioning method because the use of metal sheathing. Next is a difference between pre-tensioning and post-tensioning method. So, first pre-tensioning method, it is cheaper because there is no expenditure on sheathing etc. It is cheaper because in this method metal sheathers are not used. It is costly because use of sheathing etc. It has more certainty about the durability. There is a dependence on the two anchorage. Loss of pre-stress is more. Loss of pre-stress comparatively less than the loss of pre-stress in pre-tensioning method. Method is suitable for factory. Method may be employed for precast or cast in situ members. So, pre-tensioning method is suitable only at factory, whereas the post-tensioning method is suitable in factory as well as at site. The size of member is limited because heavier and longer member are more difficult to transport. Size of member may be of any, since the member can be pre-stressed in the field. So, these are the difference between the pre-tensioning and post-tensioning method. Now, system of pre-stressing. There are three system of pre-stressing. First one is the Fressinet system, second one is the Magnet-Blatten system, and third one is the Lee-McCall system. So, student, let us discuss first system of pre-stressing, Fressinet system. This method developed by the French engineer Fressinet is one of the most widely used post-tensioning method of pre-stressing. Engineer Fressinet developed this method, and this method is used for post-tensioning method. High tension steel wire 5 mm to 8 mm diameter, 8, 12 or 16 in number are grouped into a cable with helical spring inside. The spring keep proper spacing between the wire. It also form a channel for cement grout. In this system, 8, 12 or 16 number steel wire of diameter ranging from 5 mm to 8 mm are grouped together with helical spring inside. So, these are the wire. This is the helical spring inside the wire. This is the metal sheathing. So, the function of the helical spring is to keep the wire well within the positions. The whole thing is enclosed in a flexible tube or sheathing of 32 gauge metal sheet. The cable project about 80 mm beyond the end of the tube. The project length enable to tensioning the jack to have a grip for stretching the wire. The cable, which is about 80 mm beyond the end of tube, is used for jack grip. The anchorage consists of a cylinder of ordinary good quality concrete and is provided with the corrugation on the outside. It has a central conical hole and is provided with heavy hoop spiral reinforcement. This cylinder is called female cone. So, in diagram, this is female, this is the female cone, this is taper from inner side, this is taper portion, and outer side is corrugated surface. This is the cross section at YY of female cone. These cylinders are kept in the proper position, and the conical plug are pushed into the conical hole after the cable are tightened. The conical plug is precast reinforced concrete cast around a steel tube. The conical plug is known as a male cone. So, in diagram, this is male cone, this is male cone, and this is the cross section at x axis. This male cone is pushed into this female cone for tightening the wire. Through the hole in the plug, the cement mortar is pumped to the grout, the space between the wire after pre-stressing. This is an additional help in preventing the wire from slipping. So, from this hole, cement can be grouted in this tube. This is the concrete block, this is the high tension steel wire, this is the metal sheather, this is the female cone, this is the male cone, and this is the tube for grouting, and cement cement is grouting through this hole of male cone. Next is advantage of Fressinet system. First advantage of Fressinet system, securing the wire is not expensive. So, wire are cheap, not too much expensive. The desired stretching force is obtained quickly. The plug may be left in the concrete and they do not project beyond the end of the tube. Disadvantage of Fressinet system, all the wire of a cable are stretched together, hence the stress in the wire may not be exactly same. Wire are stretched all together, therefore, all wire are not equally stressed. Second disadvantage is the greatest stretching force applied to the cable is from 250 kilonewton to 500 kilonewton. This may not be sufficient. So, we are unable to apply the full stretching force in Fressinet system. The jack used are heavy and expensive. So, this is all about the Fressinet system of. Second method is Magnol-Blatton system. Second system of pre-stressing is Magnol-Blatton system. This system was developed by Professor Magriel and contractor Blatton, both of Belgiums. The principle on which this method are based upon, first one is the wire must be placed in definite order and not at random. There should be a sufficient between all the wire in cable, space must be left to allow easy injection of cement grout in order to protect wire from corrosions. So, there should be a sufficient space between the wire for cement grouting. Third step, only two wire should be stretched at a time so as to obtain a practical uniform stress in the wire. So, this system wire are not stretched altogether, only two wire are stretched at a time. In this system, the cable consists of any even number of wire up to 60